Welcome to lecture 15. We are going to continue with our discussion on marginal analysis. Recall that in the previous lecture, lecture 14, we introduced this notion of marginal analysis, right? What we said was that this is the idea of taking small steps. So, the example that we are currently looking at is a firm. So, let us say the firm is producing CDs, right? It could be any good, pens or pencils, but the example that we are taking is a firm which is producing CDs. There is an inverse demand curve which is given by P as a function of Q equals 6 minus 3Q by 5000, right? Using the inverse demand curve, we have computed the total revenue. Then we are also given the total cost of producing the CDs. So, that is the sum of the fixed cost and the variable cost. The fixed cost is independent of the output. The variable cost is a function of the number of CDs produced. So, subtracting the total cost from the total revenue gives us the profit, and the firm's objective is to find out the number of CDs it should produce in order to maximize its profit, right? We have not yet solved the profit maximization problem. We will do that in just a few minutes. But we started by saying that suppose you are leading a team in the shop floor and the team is currently producing 1000 units. How do you convince your team that producing Q equal to 1000 is not optimal and you can do better than that? Better in the sense of improving your profit. So, we can use marginal analysis to answer that question, and we said suppose the firm is currently producing 1000 units and you tell the firm to take the next step. The next step for the firm is producing one more unit. So, I increase the output from Q equal to 1000 to Q equal to 1001, and then I ask, has the profit increased by taking this one step? So, what we did was we did the simple arithmetical exercise of computing what the price of 1000 units were. So, that is 5.4 per unit, the total revenue obtained by producing and selling 1000 units, and of course, the total cost of producing those 1000 units, which is giving us the profit of from producing 1000 units, right? When the firm takes one more step, when it produces one more unit, notice the price will no longer be 5.4 because now the firm is selling 1001 units and the price has to be 5.3994 per unit for the firm to be able to get the buyers to buy 1001 units. The total revenue also changes, the total cost also changes, and therefore, the profit changes. Now, a simple look at the numbers tells us that when the firm takes this one extra step and increases its output from 1000 to 1001 units, its profit increases from 3200 to 3203.3994. So, clearly that tells us that Q equal to 1000 is not optimal. We sharpened this analysis by saying, let us define three marginal terms. We defined the marginal revenue as the change in total revenue resulting from a unit change in the quantity produced. So, if you notice, marginal revenue is the change in total revenue resulting from a unit change in the quantity produced. Total revenue is in rupees, quantity is in the number of units, so the marginal revenue is in rupees per unit. Similarly, marginal cost is the change in total cost resulting from a unit change in output. So, that is delta TC divided by delta Q. The units of marginal cost also are rupees per unit. Finally, we can write down the marginal profit as the change in profit resulting from a unit change in output, that is delta pi divided by delta Q. Okay. Now, we can compute the marginal revenue in numerical values by simply computing the marginal revenue as the total revenue of producing 1001 units minus the total revenue from 1000 units divided by 1. Similarly, the marginal cost is total cost of 1001 minus the total cost of 1000 divided by 1, and the marginal profit also is the profit from 1001 units minus the profit of 1000 units divided by 1. So, if we compare this arithmetic, the main takeaway was that when marginal revenue is greater than the marginal cost, which implies that the marginal profit is also positive, the firm is actually wanting to increase the output. So moving from Q to 1001 is actually an optimal choice for the firm. When marginal revenue is less than the marginal cost, then marginal profit is negative. So producing that one extra unit is going to lower the profit. It's going to bring you down your profit hill. So the firm should not be taking that step and increase output. Rather, it should decrease output. So profit maximization arises when marginal revenue is exactly equal to marginal cost, which is that the extra revenue that the firm gets by producing an extra unit of output is exactly equal to the extra cost incurred by the firm to produce that extra unit of output. Okay. So now let's compute the optimal Q star. So we want to compute the optimal Q star. Okay. For that, we will use the tools of calculus to compute what the Q star is. The marginal analysis tells us in which direction the firm ought to be going. Just as when you are trekking up your hill to reach the top of the hill, the marginal analysis is that you take that extra step, and if that extra step takes you to a higher point on your hill, it means that you are heading in the right direction, that you want to be taking that step. On the other hand, if that extra step takes you to a lower point on the hill, then you actually want to move backward, you want to take the step the other direction. Okay. So I want to compute the marginal revenue and the marginal cost. Recall the expressions of total revenue. The expressions of total revenue is 6Q minus 3Q square by 5000. The total cost is Q plus Q square by 5000 plus 1000, and the profit is the revenue minus the cost. So that is 5Q minus 4Q square by 5000 minus 1000. Now the marginal revenue is the change in total revenue resulting from a change in output, from a unit change in output. For very small changes, right, as my delta tends to 0, I can borrow the rules from calculus and claim that delta TR delta Q is approximately dTR dQ. That is essentially the derivative of the total revenue function. Now if you look at the derivative of the total revenue function, that is going to be the derivative of 6Q minus 3Q square by 5000. Well, that is going to give me the derivative of 6 times Q. So I can pull the 6 out. The derivative of Q with respect to Q is going to be 1. So the first expression is going to give me 6. For the second term, I have minus 3Q square by 5000. The 3 divided by 5000, I can essentially pull it out, and the derivative of Q square with respect to Q is going to give me a 2 times Q. So the 2 multiplied by 3 upon 5000 is going to give me a 6Q divided by 5000, right. So I am just taking the derivative of the total revenue with respect to Q, and we get the marginal revenue as a function of Q. Similarly, I can compute the marginal cost as delta TC over delta Q, which is approximately the derivative of the total cost function with respect to Q, right. So for very small changes in delta, as my delta tends to 0, my marginal cost is dTC dQ. So if I take the derivative of this expression, the 1000 is just a constant. The derivative of a constant with respect to output is going to give me 0. So that is not going to matter. The derivative of the first term here, Q with respect to Q, is going to give me a 1, and then the derivative of Q square by 5000. So 1 upon 5000 will come out. The derivative of Q square with respect to Q is going to give me a 2 times Q. So that is going to be 2Q divided by 5000. Now I already know that the marginal profit is marginal revenue minus marginal cost. So I can simply subtract the marginal cost from the marginal revenue and write it as the marginal profit, rather the marginal profit. This is the marginal profit. Okay. So let me just write this clearly. So this is the marginal profit, right. So that is either the marginal cost minus the marginal revenue minus the marginal cost, or I can simply take the derivative of the profit function delta pi delta Q, which is the same as d pi Q dQ, and write it as the derivative of 5 times q with respect to q. The 5 will come out, the derivative of q with respect to q is going to be 1. So, 5 times 1 is 5 minus the derivative of 4q square by 5000 with respect to q. Now, notice here 4 upon 5000 will come out. The derivative of q square with respect to q is going to give me a 2 times q. So, that is going to give me an 8q divided by 5000, and the minus 1000 is essentially going to not contribute at all, because the derivative of a constant with respect to q is going to be 0. Now, I would have gotten the same answer even if I had subtracted the marginal cost from the marginal revenue. Notice, if I had subtracted 6 minus 1 would have given me a 5. I would have had a minus 6 by 5000 q and minus 2 by 5000 q, which will give me a minus 8 q by 5000. So, the optimal q star will satisfy marginal revenue. So, the marginal revenue at q star is equal to the marginal cost at q star, which is the same as saying that the marginal profit at q star will be equal to 0. So, if I set the marginal revenue equal to marginal cost, that is the same as saying that the marginal profit is going to be equal to 0. Since we have already computed the marginal profit, that implies that 5 minus 8 q star by 5000 is equal to 0, which then implies that q star equals 25,000 divided by 8. If we do the arithmetic, we will find that the optimal q star is 3125. Right. So, the profit maximizing q star is going to be 3125. Now, notice here I just took the first derivative. For any maximization, as we said earlier, there is also a second derivative, but for most of the functions that we will see in this course, we will either have these nice inverted u functions if it is a maximization problem. So, I know that if I am at the top of the hill, that is going to be the unique maximum, right. So, I am not going to check the second derivative here, but you can very easily check that the second derivative of the profit with respect to q, if I were to check the second derivative, that second derivative is going to give me minus 8 by 5000, because that is going to be the derivative of this expression with respect to q, which is going to be less than 0. So, it is indeed the case that we are solving for a maximum. So, q star equal to 3125 is going to give us the optimal quantity to maximize the profit. Okay. Now, what is the difference between the two approaches that we did, right? So, the two approaches complement each other, right? The marginal analysis, the first analysis that we did, we started with q equal to 1000 and then we moved to q equal to 1001. That told us in which direction the firm ought to go. So, we learnt that the firm should be moving in the direction of increasing the output. The second analysis, so notice, if I went from q equal to 1000 to q equal to 1001, then I ask, is q equal to 1001 the optimal? Well, again we will do one more step of marginal analysis. We will increase the output from 1001 to 1002, then from 1000 we will repeat the same analysis, then we will again take one more step 1001 to 1002. If the profit still increases, we will move from 1002 to 1003, and we will keep on doing these steps. Notice that is going to be a time consuming process. So, calculus is useful in the sense that it gives us exactly what quantity q star to produce. And in the last class, I asked you to check whether q equal to 4000, right, at q equal to 4000, what do you learn from the marginal analysis? I would urge you to again go back to that to your computation. You will find that at q equal to 4000, the marginal profit will be negative. That tells you that increasing q is going to cause the profit to fall. So, what the firm ought to do is it ought to decrease the profit, and that is consistent with the answer that we got here, because the optimal q star is 3125. So, if the firm is currently producing 4000 units, it is producing far too many number of CDs. What it ought to do is ought to reduce its number of CDs in order to maximize its profit. Okay. So, the q equal to 3125 is the profit maximizing q star. There is one additional subtle point that I want to talk about here as to what is the difference between price. So, is the price P and marginal revenue the same, right? So, are the price P and the marginal revenue the same, right? So, are the price and the marginal revenue the same. Okay. Now recall the definition of marginal revenue. This is the change in revenue when from a unit change in the output, right. So the marginal revenue when the firm increases its output from Q equal to 1000 to Q equal to 1001 is 4.7994, right. So the marginal revenue, so let us make a note, the marginal revenue for the firm when it increases its output from Q equal to 1000 to Q equal to 1001 is rupees 4.7994, which is to say per unit, that when the firm is producing and selling the 1001th unit, the extra revenue from the 1001th unit is this number, right, 4.7994. Okay. Now, what is the price when the firm sells 1001 units? Notice we have already computed the price. The price when the firm sells 1001 units is 5.3994. The price when the firm sells 1001 units is rupees 5.3994 per unit, right. So, by simply looking at the numbers, notice that the price and marginal revenue are not the same, right. Simple arithmetical exercise tells us that they are not the same. But what is not so obvious is the following feature. When I am selling 1001 units, right, when the firm is selling 1001 units, it is charging a price of 5.3994 per unit, right. So, it seems that for the 1001th unit in particular, unit is also sold for rupees 5.3994, isn't it? Because for every one of the units from the first unit till the 1001th unit, the firm is charging 5.3994 per unit. So, when I am selling the 1001th CD or the 1001th pen, the buyer is paying 5.3994. However, the change in revenue that the firm experiences is not 5.3994, the change in revenue is only 4.7994. The extra revenue that you get from the 1001th unit is only 4.7994. So, price and marginal revenue are not the same, right. But what is going on here? And this is the subtle argument here, subtle point here rather. So, first consider the case when the firm was selling 1000 units, right. So, I have the first unit, I have the second unit, the third unit, and I have all the way until the 1000th unit, right. For each one of these units, right, the price that the firm was charging is actually 5.4. Recall, when the price is 5.4, so the price for 1000 units is actually 5.4 per unit. For every one of these units, the firm was charging a price of 5.4. So, I will just put down 5.4 here to indicate that for each one of these units from the first to the 1000th unit, the firm is charging a price of 5.4. However, when the firm now wants to sell 1001 units, when the firm wants to sell 1001 units, and let us put down these 1001 units here, the first, second, third, the 1000th unit and the 1001th unit, right. So, for each one of these units, the firm has to reduce the price to 5.3994, 5.3994 for all of these units, right. Because if I continue to charge 5.4 per unit, I will not be able to sell 1001 units. If I charge 5.4 per unit, the number of units that I will be able to sell is only 1000 units. So, the key takeaway here is that to sell one more unit, I had to reduce the price By how much? So, originally I was charging 5.4, now I am charging 5.3994, right. So, I had to reduce the price by 0.0006 rupees per unit, right. Every unit previously, that from the first till the 1000th unit that I was selling earlier at 5.4, now I have to sell by at 5.3994. So, the price reduces by 0.0006 rupees per unit. So, on every one of these units, from the first unit till the 1000th unit, I had to reduce the price by 0.0006. So, when I sell the 1001th unit, so the marginal revenue, the change in revenue from this additional unit, I am selling it at 5.3994, right. This is the price for all the 1001 units. So, in particular for the 1001th unit, the price is 5.3994. However, I have lost 0.0006 on every unit from the first unit till the 1000th unit, right, because I had to lower the price. So, this is how much I have lost. So, this is nothing but 5.3994 minus 0.60. If you do this arithmetic, you will find that this is 4.7994, right, which is exactly the marginal revenue that you got here, right. So, price and marginal revenue are not the same. Well, that is immediate by simply looking at the two numerical values, right. But what I want you to focus on is, why is it that the price and marginal revenue are not the same? The only way I can sell 1001 units is if I lower the price, not just on the first unit, but on every single unit from the first unit till the 1000th unit, right. I had to lower the price. So, the marginal revenue when I sell the 1001th unit is essentially the price minus what I have lost on every single unit from the first unit till the 1000th unit. Okay. So, in this example, price and marginal revenue are not the same. Can the price and marginal revenue be the same? The short answer is yes. A little later, towards the latter part of the course, we will come across a particular instance, a particular case of a firm where the price and marginal revenue are the same. We will talk about that when we look at that particular market structure. Okay. Now, I've solved the problem in two ways. One, by looking at a marginal analysis from Q equal to 1000 to 1001. We then used the tools of calculus to figure out exactly what the Q star was. Let me show you a third way of looking at the same problem, but this is a more pictorial representation, right. So, let us get all the functions here so that we do not have to keep going back to the previous pages. So, that is 6 minus 3Q by 5000, total revenue is 6Q minus 3Q square by 5000, total cost is Q plus Q square by 5000 plus 1000, and the profit is 5Q minus 4Q square by 5000 minus 1000, and the corresponding marginal revenue terms also are with us, right. 6 minus 6Q by 5000, the corresponding marginal cost is 1 plus 2Q by 5000, the marginal profit is 5 minus 8Q by 5000. So, this information is with us, right. Now, what I want to do is, I want to draw the pictures one below the other. So, I first want to draw the inverse demand curve. On the graph below, I want to plot the total revenue and the total cost. These are in rupees. On the graph below, I want to plot the marginal revenue and the marginal cost. These are going to be in rupees per unit. And in the last graph, I am going to plot the profit. or the marginal profit if you prefer, right. Now, it's better if we plot the profit. So, let us stick to profit. In fact, I can plot the marginal profit also in the graph below, but that is I do not have space here. So, I will separately draw it to the right. Now, the inverse demand curve we already know, we have drawn it before. So, that starts at 6 and this is Q equal to 1000 or 10,000, right. At Q equal to 10,000, the price is going to be equal to 0. So, that is the inverse demand curve. Total revenue 6Q minus 3Q square by 5,000, right. This is going to be an inverted U-shaped curve, right. I know that. So, the way to draw these pictures is take different values of Q, right. So, once you get different values of Q, you will start, you will observe a particular trend, and I know that it is non-linear, right. I see a Q square term here, and because of this minus, this is of the form AX minus BX square, that is sort of an inverted U or a parabola. So, at Q equal to 0, I am going to get the total revenue as 0. You will also find that at Q equal to 1000 or rather Q equal to 10,000, Q equal to 10,000, the total revenue again is going to be 0. The reason for that is at Q equal to 10,000, the price will become 0, and therefore, even if you are selling 10,000 units, but you are charging a price of 0, your revenue is going to be 0. So, if you connect those two and take different values, you are going to get a total revenue which is going to look like this. So, this is your total revenue curve, okay. This is the total revenue curve, the one in black is the total revenue. And for total cost, let me use a different color. Total cost is Q plus Q square by 5,000 plus 1000. This is also non-linear, and I know that total cost is going to start at Q equal to 1000. So, total cost is going to be somewhat like this, right. So, as you keep adding more and more, as you keep producing more and more units of output, your cost is going to increase, and it will follow this particular trend. Again, take Q equal to 100, Q equal to 150, Q equal to 1000, you will get the trend. Okay. Now, let us look at marginal revenue. Now, pictorially, suppose let us say I don't know the functional form, right. Here I have the function 6 minus 6Q by 5,000, that is a straight line and it is a downward sloping line, but I can compute the marginal revenue by simply looking at the total revenue function. So, let us say I have the total revenue. So, let us say I have the total revenue as follows. This is my total revenue, and let us say I want to compute the marginal revenue. So, the way to compute the marginal, so the marginal is the derivative of total revenue with respect to output. So, essentially the derivative is nothing but drawing the tangents to various points to the curve and finding the slope of the tangent, right. So, if I wanted to draw the tangent at various points, so at this point if I wanted to draw a tangent, notice that the angle made by that tangent is going to be some line here, right. If I look at the top of the revenue hill, the tangent is going to be perfectly flat, right. And if I were to look further to the right, the tangent is going to be somewhat of this, it is going to be downward sloping, right. So, on this portion, I know that the tangent is going to be upward sloping, right. But notice those angles are becoming flatter and flatter and flatter, right. So, the tan values are becoming smaller and smaller. So, my marginal revenue in absolute, the value of marginal revenue is going to decrease. At the top of the hill, the marginal revenue is going to be exactly 0, and to the right of this point, the marginal revenue is going to start getting negative, right. So, if I connect, I am going to get a trend like this, okay. Similarly, we can also draw the marginal cost. In our next lecture, I will put all of those together in the marginal revenue, marginal cost graph.